In this video, we will demonstrate the FileNet P8 export connector. In order to show the capabilities of this connector, we've prepared a dataset featuring versioning, ACL, and custom metadata. For example, this file has several versions and security policies. To show the managing of custom metadata in documents, we've implemented a data model including content types such as agenda and brochure, which you can see here. Each content type has custom properties. Now we will show the UDM database, where the metadata of the content in FileNet P8 is stored. The UDM is our one-size-fits-all data model, which we use to store metadata from content systems in order to integrate them. Here we see the source of the data, which is visible in FileNet. As you can see, every document has a number of attributes, which are neatly defined and standardized. Also, permissions are included, and in case of document types, there's version content and custom content. Let's take a look at the UDM in a conceptual way. The UDM is structured in a layered way. It's composed of a set of standard decorators, which are comprised of the most common metadata fields in content management systems. We also include separate connectors to and from the UDM, one to export from a source system to UDM, in this case FileNet, and one to import data from UDM into FileNet. In this demo, we will concentrate on exporting from FileNet to the UDM. The connector is mostly standard software in which mappings can be added to translate the content from the source system to the UDM. In most cases, the source system has been customized beyond the standard metadata fields, and so we also have a custom layer of decorators to match this customization. Mappings are created to adapt the metadata of the source system to the UDM, but in some cases, the information can't be found in one system alone. Therefore, it's possible to add additional sources to the migration process. Another possibility is to add business rules, which results in more complete data in the UDM. Now we open the Xill IDE and load the demo FileNet project. This is the project that will migrate data from FileNet to our file system and database. This is a standard project and contains 4 directories. The configuration directory contains mappings specific for this migration. They will take into consideration the document types that are present on the source system. Let's take a look at how a mapping is done. Every mapping has 3 functions. One that converts the name of the mapping to and from its representation in the source system. Then we get the parent mapping to be applied before the current one. This allows us to divide the mappings into a hierarchy of types, which can be applied incrementally in order to obtain a completely formed migrate type. And the last one accomplishes the mapping between the metadata elements in the source system and the UDM. In this case, we see that the agenda document has additional information besides its default and generic content. Examples include a meeting descriptor and another attribute, which is a list of items to be discussed at the meeting. All mappings look the same, and the function resolving the mapping to be applied to a certain content type is generated by our mapper library. Besides the config directory, we have the connector itself. This is a separate project and contains all the API needed to interact with the target system. And in a migration, this is just a dependency. As we can see, there are several library files that will be imported by the robot performing the migration. Then there's a library directory containing all shared libraries used by this project. Libraries are also a separate project and are usually not changed because the code is very well tested and documented. Finally, there's a project directory containing the main robots for the migration. Another important feature is the properties of the project. The project is completely configurable, so the source code of the project shouldn't change if we decide to export to a different UDM database, or to connect to a different FileNet P8 instance, or even choose to store the binaries in a different directory. This migration needs a preparation step before the export can be performed. In the preparation step, the custom UDM model is installed, and in general, any initialization necessary in FileNet or the UDM is performed. In this line, the proxy is started. The proxy has been developed to support the security model of the FileNet P8 platform, which is currently incompatible with the Xill runtime engine. Its class loader hierarchy is not compatible with the FileNet P8 security model based on JAWS. Therefore, we developed a Restful Proxy, which we're starting now, to broker the requests of the Xill runtime to FileNet P8. It also performs caching and keeps the state of the persistent objects running in the proxy itself. We see here what the proxy looks like. It's supported by Swagger and should be self-explanatory. We have a reference API, which shows the state of the proxy, the core API, which opens and closes sessions towards FileNet, and the command API, which brokers the requests from the Xill IDE regarding content on the target system. We have all sorts of methods to interact with documents, folders, users, versions, and so forth. Once the proxy is running, we can do the export by clicking on the play button on top. Now the documents are downloaded to the UDM. Now that the migration is finished, let's take a look at the exported files. You'll see that the complete hierarchy has been translated. For instance, when we take a look at the agenda document we've seen before, we can see that the document has different versions, which means that the migration was successful. When we look in the UDM database, we see that all content from FileNet has been exported to the UDM. Here we see the ACL. Let's take a look at the agenda document again. Clearly, it's been exported, including the custom metadata, the agenda items, the ACLs, the state of the migration, and all the versions. This concludes our video. Thanks for your attention.